to allow.
Whilst Deborah is sharing her screen, can we kindly put on our cameras so that it's not just the two of us and we can all see each other's faces? Thank you.
Um, okay, I can share my screen now. Thank you, Asada. Okay, so I believe everyone can still hear me.
Yes, we can.
Okay, all right. So thanks once again. So for the session today, so basically this session is going to look at data manipulation and exploration with NumPy and Pandas. But before the main session getting into working with data, I would want to walk over a bit of beginner intro into NumPy and Pandas, what these two are, what they are used for, and just some few uses of them. So for instance, for NumPy for beginners, we'll just walk over its installation, how to create NumPy arrays. We'll look at indexing with NumPy and NumPy slicing and some other built-in methods that exist in NumPy, and briefly look at broadcasting. And there will be some exercises, but for these exercises, I would encourage you to try them on your own. We'll do the same for pandas. We just look at the installation, walking through data frames in pandas and how to index and select data using pandas, and also some other existing methods in pandas, and then how to load files in pandas and some exercises. Again, for these exercises, I would encourage you to try them again on your own. And where I would want everyone to get involved is working with a data set, Titanic data set. I am working with my Jupyter notebook on my local system, but I have the same notebook uploaded on Google Colab, which you would have access to. And once we get to the part where I would want us to work together, I would share the link to it so that you could also follow along. So to start, NumPy for beginners. So basically, NumPy in itself, hopefully anyone familiar with what a library or what a package is in Python. If anyone knows, maybe you can just say a yes in the chat there. I'll try to monitor there. Anyone familiar when you hear a package or a library in Python? Is anybody listening to me? Okay, yes, from Frank. Any other person? Okay, so basically, when we talk about packages or libraries, you can think about them as tools that enable you to complete a task. So let's take it that you want to, let's say, build a linear regression model. And to build a linear regression model, there are different methods you can use to build a linear regression model. So you can use like the least squares method. And the least squares method, you need to first of all be able to find the equation for a linear regression is like a y is equal to beta naught x plus beta 1 x2 blah blah blah. So you need to be able to find your coefficients, your betas, and these betas also have formulas. So for you to be able to complete this, it's either you can sit down and rewrite all of these things by yourself so that you're able to take a data set, find the coefficient, and then fit it to whatever data sets you have. And this means that if you really don't understand how linear regression in itself work in practice, it's going to be very hard for you to actually sit down and be able to write a full code that will help you do this. But we have libraries in Python that enables you do this. What that means is that someone who already understands this has been able to sit somewhere and write series of codes that is able to pick whatever data set you give to it, and then come up with complete coefficients that you need for whatever data set you're working with. And this therefore makes it easy to complete the task of linear regression. So that's basically a library in Python. So NumPy is also a library in Python that enables you do a lot of things. So it basically stands for numerical Python, and it's used to work with numerical data. So you'll be working with a lot of data as data scientists or machine learning engineers. And so NumPy allows you to pick whatever data set you have. And if you have to calculate, let's say the mean, you have to calculate the mode, you want to calculate the standard deviation, think about different mathematical formulas that you want to do with your data. NumPy allows you to be able to perform all of those operations. Secondly, NumPy API in itself is extensively used in other libraries, say Pandas, and we'll look at Pandas, what Pandas is, and other visualization libraries like Matplotlib or Scikit-learn, which is basically used for most or contains most of the machine learning packages that we have in existence in Python. So basically, that what you should pick up from this is that NumPy stands for numerical Python and allows you to be able to manipulate numerical data in Python. That is what NumPy is. And if you have to install NumPy, you can install it using conda install NumPy. But if you use this, you need to make sure that you have conda. You already have conda on your system installed. So you can have the conda install NumPy, or you can use the pip installation. But all of this sometimes can be very confusing for someone who is not like is just beginning programming. It's hard to do all of these installations. And so usually it's important to use Ana- Anaconda, and I sent a link with to all participants that registered on our meetup page how to download Anaconda. So this is for your personal use. If you decide that you want to continue learning this after the session, so you can ensure that you download Anaconda, and Anaconda allows you to have all of these packages like NumPy, Pandas, and a whole lot of other existing libraries in Python without necessarily having to download them, install them yourself. So that's why it's important using Anaconda. But for the session today, we would use Google Colab. You work with that. And again, with that, we wouldn't have to install them. They are already like sort of, I would say, pre-installed. So you don't have to install them. So this is just basically, yes. I thought someone was talking. Okay, so this is how basically you go about installations of NumPy. So once you have this installed, to now use NumPy to do anything. For instance, let's say I am in a room and I have a friend who is called Salome in the other room, and I need Salome to help me, let's say, pick up an item or a bag. If I call Salome like if I just say Salome with a low voice, or Salome is not anywhere inside the room, so there's no way she's going to hear me. So I can't use Salome's effort to help me pick the bag. But then I have to call Salome from wherever she is so that she comes into the room so that she can help me pick the bag. And that is what is similar with NumPy. Though you can have NumPy installed in your system, if you have to use it, you need to first of all import it. So you can think about importing NumPy as calling it. So you're calling it that, hey, I want you to come help me do this. And to import it, the key word you need here is import. So for whatever package you're using or library, this word is very important. Import, and then the name of what it is. So in this case, it's import NumPy. Now, as NP, this is necessary because it's just more like convenience sake. I don't want to always all the time have to say NumPy. I want a short form to always refer to this NumPy. For instance, in our daily life, someone call, let's say Josephine. Most of the time, instead of calling the person Josephine, we say Jojo because it's a short form. So anytime we say Jojo, whoever is called Josephine responds and knows that we are referring to him or her. So it's the same thing that happens with this too as well. So we say import numpy as np. So anytime we see np, we know that we are referring to numpy. So now once you have imported this, so when we say import a library, it's just this one code. So once we have imported this, we then can be ready to use NumPy to do whatever we want to do. So for example, we decide that we want to create a NumPy array. And to create a NumPy array, we need to be very careful. What we first of all need is np.array. We need np.array, and then we need first of all a close brackets. First of all, a close bracket, and inside that we put in square brackets. This is a very important thing to be able to create any NumPy array. So you just call np.array. So this array is a method in NumPy, and then we are saying we want to create an array, and to create it, we need those double bracket and then a square bracket. So once we have this inside the square bracket, we can now put whatever information that we want. So in this case, we are creating numbers 1 to 10. So inside the square bracket, we had 1, 2, 3, 4 to 10. And we name this, or we say all of this array, we are referring to it as array. So which means that anytime we call array, then we are referring to this entire thing we have created here. So we run this, and then we are printing the array, and then we have the total list created for us. This is just an example of how this NumPy is used. So to be able to create NumPy arrays, they are different. Already, I mentioned that it's just used to work with numerical data. So which means that there are several ways that we would want to create this NumPy array depending on what we want to use it for. So for instance, we can create using Python list, which is what we saw at first, by just np.array, then the brackets, and then we have the square brackets, then we put in whatever information that we want. And that basically is how to create a NumPy array using a Python list. Secondly, we can also create arrays of zeros, for instance. So what that means is that we want an array, but we just want it to be zeros. We could create it the same way by just saying having this and having zeros inside. So 0, 0, 0, 0. But this is just like you're repeating the thing, and you wouldn't want to go through this stress of writing the same thing over and over again. So we can create just zeros, and to create that, we use np.zeros. I should mention that it's not necessarily that you have to remember all of these things like np.zeros, np.ones that we'll be saying. Sometimes it's good you know the documentation and know that these exist. And when you want to do it and you're not sure what the exact name is, you can always go online and use Google. Like, because it's sometimes, I mean, even those of us who use it, sometimes you forget, like, okay, what is this thing? How do you get the like an array of only this or something? So you don't, it's good if you know them, yes, but it's not a must that you have to memorize all of them, all of the methods in NumPy. And pretty much it's probably not going to be it's not going to be possible to remember everything. You probably remember the ones you use very often. So to create an arrays of zeros, we have np.zeros and then brackets. Then we write what do we want, the number of zeros we want. So we want like an array of 10 zeros. We are seeing something new here, which is D type. So what this means is the data type. So basically in Python, we have different data types. So for our last month session, Khadija walked us through different data types in Python, and we have different types. So in this case, this is like an integer. So we can also create an NumPy array of zeros with a data type like floats. So we create this zeros, and then we have our arrays of zeros. So this is another way if you want to create just zeros. On the other hand, you could also want to create, let's say, a matrix, right? So to create a matrix, you know that you have rows and you have columns. So if you want to create a matrix using NumPy, or you can create a NumPy matrix of ones, for instance. We could also make it zeros. That means we just want it to be zeros. So it's np.1, so it's just going to be 1, 1, 1, 1. And in this case, we want, usually with any matrix, we read it row by column, row by column, row by column. So in this case, we want to create a 3 by 5 column matrix. So we specify how many rows and then how many columns. And then we again include the D type that we want it to be a float. We could also say we wanted the D type to be an integer, and it would create the same for us. So if we run this, then we have our NumPy array created for us. We could also create a NumPy array with fixed values. So in this case, we can create a NumPy array of a 3 by 5 matrix, and we want it completed with 1.23. We could change this value to be a 1, to be a 2, whichever one we want. And when we run this, we have our array created for us. So this is how we can also create like a matrix if we want some predefined value. Also, it's possible that you want to create an array based on certain sequence. So in this case, there are several ways we can do this. There's one we call the NP arrange. And with that, what we need to know is that it takes the first value you indicate is where you want to start from. So what do you want? Where do you want to start from? Which value do you want to start from? And then the next value you include is where you want to stop. And then the last is how much step you want to take. So in this case, we have NP arrange, then we have 0, which means that we want to start at 0. And the second value is 20, which means that we want to end at 20. And then the last is step, which means that we want to take a step of 2. And then when we run this, we notice that we have 0, 2, 4, 6, 8, 10, 12, blah, 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 18. Who knows why we are not seeing the 20 there? Because, I mean, we asked that we want to stop at 20. Why do you think this did not stop at 20? Anyone? Anyone? Just, I mean, even if you're not sure, just feel free and you can write it in the chat, or you can unmute yourself and share why you think that Python did not include 20. Anyone? Anyone willing to try? Your line is breaking. Your line is breaking. I'm sorry I missed it. Hello. Okay. I think I didn't hear what this person was saying, but you're free to also type in the chat. But I'll just continue for the sake of time. So basically in Python, one thing we need to know is that when you are looping a list, doing anything, and you wanted to get to a certain value, usually what happens is that it doesn't like add that last value. So for instance, if I okay. So in this case, we say it should stop at 20, but we are taking a step of 2. So which means that this is going to stop at 18 because Python wouldn't include this last value that we have indicated. So in the event where we wanted this to stop at, let's say 20 exactly, like 20 to be included in this list, then that means that we probably will have to make this 22 so that 20 is included. So usually like it's always, you can think about it that it does it minus that last value, whatever you're doing, it's minus that last value. And maybe I should mention, okay, when I get there, I'll mention it, but basically that last value, it's usually not included whatever you're doing, right? So arrange is one way to create a set of sequence. Another way to create is what we call the linked space. And the linked space also takes the start, the stop, and then the number. So if you want to create an array using any of these things and you're not sure, you can go and just search for, let's say, NP arrange. There is usually documentation for it. So you can go and you can search for NumPy documentation, for instance, and you can open this and you can get most of the, so these are like different versions of the manual, so you can get one of them and then you go and look for exactly what you're looking for and read the documentation about it. So like I mentioned, most of these things are things that you probably wouldn't be able to keep everything in your head, so it's pretty much important that you're able to know how to search for the information yourself to complete the task that you want. So the linked space also, it's it's similar but different in the sense that you specify the start, you specify the stop, and then you specify the number. The number here is how many, like the lists of numbers that you want in it. So in this case, we specified 5, but we're saying that we want it to stop at 1 and we want it to start at 0. So it's going to create a total length of numbers that are like 5. So if we wanted 10 or 6, if we specify this, then it will create 6 numbers for us and then put the start and stop. Also, these are just like 3 major things that I have included, but linked space can take several other parameters. So you can check the documentation of linked space, and then you have the documentation of what other things you can include and what they mean if you want more complexities. Also, we can create a data that is like normally distributed using np.random.normal. So with any normal distribution, there are 2 parameters, major parameters, which is the mean and the standard deviation. So in this case, we can specify what the mean is and what the standard deviation is, and also the size. So in this case, we want a matrix of 3 by 3, and the standard deviation is 5, and then we want the mean to be 0. So if we run this, then we are going to have this created for us based on what I have indicated. Like you have a mean of 0, standard deviation of 1, standard deviation of 5, whichever one. And we want this to be a 3 by 3 matrix. We could also create identity matrix using np.I, which is a 2 by 2. So if we run this, an identity matrix is basically one, like having 1 in every row and then the rest being 0. So you have 1 and the rest zeros. In the second column, you have 1 at that second column position 2 by 2 and the rest 0. So in that way. So if you want, let's say a 5 by 5 identity matrix, then we have this. So these are just some of the things how you can create different series of data using NumPy. Now to the most, so I don't know if there are any questions here, first of all, before I move on to like the most important part and sometimes very confusing part when it comes to NumPy. Any questions, please? If you have a question, you can either leave it in the chat or you can unmute yourself and just ask me directly. Okay. Priscilla, do you have a question? Okay, I think maybe she unmuted by mistake or something. So moving on to NumPy array indexing. So this indexing, basically, you can think about how to, if you have an array and you want a particular value from the array you have created, how do you get that value? How do you select that is this particular value you want? Maybe the value is in the 3rd position, the 4th position. And this is pretty very, very important. And so when we are doing indexing, one thing that we need to know is that Python statistics count at 0. So what that means is that if I have a NumPy array that has been created, let's say this is my NumPy array I have created, what it means is that this value at 3 has a position of 0. We don't start at 1. And this how Python counts. So we are going to start counting at 0, 1, 2 in that order. We don't start 1, 2, 3. We start at 0. So it's very important to always remember this. So for instance, if we decide that we want this array NP array 1, 2, 3, and we want the first value, which is 1, then we are going to index it with data, then square brackets and put in 0 because it's the first value we want. And remember, I said the first value is indexed, like we count from 0. So the first value, its position, it's 0. And if we want the second position, which means that its value is a 1. So that's how it works. So for instance, with this array, we have this, okay, NP array. It was a 1, 2, 3. Let's say I just try lists is equal to. Then I want, let's say, the last value. In this case, this is 0, this is 1, this is 2. So if I want this value of 3, then I'm going to index it with what? A 2, and this would give me a 3. If I want the 1, I'm going to say list of 0, and then I have a 1 in here. So basically just know that it starts with 0, 1, 2, 3 in that order. And if it's just a 1D array like this, it's easy to just select what you want. So in this case, we have array NP array. Maybe I should run, and then someone can tell me what they think the answer of this alone is going to be. So if I say array of 3, what do you think the answer of this is going to be before I run it? Please write in the chat. Ade, you say I should scroll up. I don't know to where is it here. Okay, someone say, Frank says 4, 4, 4, 4. Okay, let's see if it's a 4. Run this. Yes, it's a 4. And why is it a 4? Because we have 0, 1, 2, and 3. What if I had said 5, array of 5, index 5? What do you think this is going to return? If I put a 5, what will this return? What number in this list is it going to return to me? Error of index. Okay, error. Everyone is saying error. So let's try this. Yes, index error. That's because if we count 0, 1, 2, and 3, 4, there's no 4, there's no 5. So that means that you have, there's no value you should return. So it tells you that the index 5 is out of bounds for as a 0 with size 4. So another thing I should also mention is that if you're working through code too, and then you come across an error, which you're not, you write something and then you get an error, you can read what the error is. Usually they write what the error is. And if you're not sure how to deal with it, copy this error, and then you can go and then put it on Google and search. You surely index 1, blah, blah, blah. You find people with similar problems. Then you read through and see someone may have similar problem, and then you find someone who tell you what the problem is, like what you did wrong. So you can read through and then try them and see what works. So that's another thing you should take notice of whilst learning coding and stuff. Okay, so basically this, we have tried this. Array 0 would return 1, and this array, the second array is of 1, so it will return 2. And then in this case, we have, it's still the same thing. We are saying that we want array of index 2 and array of 3. What do you think this would return from this? What would this return? We are using this array 1, 2, 3, 4, and then we asked it array 2 plus array 3. What do you think this will return?
7.
7. Okay, someone say 7. Any other? I'm seeing 2. Did I see a 2? Someone said a 2? Okay, 7. Okay. All right, so let's run this. It's a 7. And why is it a 7? It's a 7 because if we take array 2, that's 0, 1, 2, this first value, that's array 2, is a 3. The value is a 3. And array 3, it's a 4, so which means that it has taken this value here, which is 3, and added to this, which is a 4, and when it puts this together we get a 7. So that is also another simple thing. I mean, you learned two separate things, but at the end you're able to merge them to do something else. That's another thing about coding. At the end of it, you don't expect to be able to write a whole script just because you've been like you're an expert, but you put in together very small stuffs, and at the end you come up with something that someone may not be sure what you're doing. But all what we did was that we know that if we want to index, this is how we index. And now we're thinking, what if we want to add the second but last, and then the last value? This is what we do. Very, very straightforward. So that's basically how to access this simple list. But also I should mention that we have what we call dimensions in NumPy array, right? So you can think about having dimensions as let's say if I give you a 1 column or a 1 row vector, it's just one dimension, it's just one value, so you can just index them like we have done. But what if I give you, let's say, a matrix, which is let's say a 2D matrix? How are you going to do this indexing? So in this case, let me run just this particular code here. So in this case, we have what? This is a 2 by 1, 2, 3, 4, 2 by 5 matrix, right? Now, in this case, this is not a 1D, this is a 2D. So if you have a 2D, like it's two-dimensional matrix, how are you going to index? Let's say you want a value, this particular, let's say you want to index just this particular value 1. You want the first value in the first row. How are you going to get it? It's pretty much like similar to what we're doing for the 1D array, but this time around, we wouldn't just be specifying just like the position, but we need to specify which particular row we are dealing with, and then we specify the position of the value that we want. So for instance, we want to print the second element on the first row. So in this case, this is what the first row. And if you want to refer to the first row is a 0. So think about it this way. We have np.array. When I mentioned that this is how we create an NumPy array, we create with just this simple list. If you want a 2D array, you're going to have a second double square bracket in that same one. So what that means is that this would be position 0. So if you say 0, you're referring to the ones in here. If you say 1, you're referring to the ones here. So it's like you have list of lists. So in this case, if we want to refer to this particular one, the entire list in here has a position of 0. So you are referring to that first row. And inside it, if you decide that you want, this is A is equal to, so if we decide that we choose A of 0, meaning that we are referring to the one in here. So you notice that it selects the entire list for us. But then if we mention that we just don't want all of this value, but then we want, let's say, this first value, which is what, 1, then we separate it with, let's say, another 0. So it would index 1 for us. So that's how we do the indexing. So let me take it again. We have this. Remember that if we want to create a NumPy array, we use square brackets. Now, that is a 1D, but if it's a 2D, we have an additional square bracket in it. If it's a 3D, an additional one. So let me deal with the 2D. So with the 2D, we have this first square bracket, then another square bracket. So using this example that we have here, if we decide that we want just this, we would say A of 0. And if we run this, we have what? This entire list given us. If we want the second list, then it's what? A of 1. And if we run this, we have all of this. But then we don't just want the entire row, but we want a specific value in that list. In that case, we separate it with a comma and put the index of that, just like we did with the 1D. So you first of all will always take the entire list, as like you give it the name, like this is position 0, the second list position 1, the third list position that. And then once you select that list, then inside it, then you can now do what you want to do. So let's say you now want to select a particular value. In our case, we want to select the first value. So the first value, remember in Python, the first value starts with index 0. So we have a of 0, and that will give us a 1. So this is how we index 2D array. If I put 0 of 3, what value will this return? A 0, 3, what would this return? If you just check and see and let me know what you think this would return. Using the same idea, the first value is the row, then the second is the column, what you're dealing with, that particular value, the position of that item. So if you have a 0, 3, what do you think this is going to return? Still using this list that we have here. Anyone willing to try? Anyone willing to try what it's going to return? Four. Isaac says 4. Any other person who knows or has an idea if it's a 4 or something else? I don't know. Do you want me to go over this particular part again, like accessing 2D array if it's not clear?
Yes, please go over again.
Okay. Okay, Allah says 4. Okay, I'll run it, but I'll go over it again. Okay, so I mentioned that with a 1D array, we had 1D array, it's just one square bracket, right? We had 1, 2, 3. And if we wanted to access this, the first value, remember that the count starts with 0. So if we want to access 1, this is the list, which is a 1D array. That's one-dimensional array. We just say b of 0. And if we run this will give us a 1. That is simple. But then if we are dealing with a 2D array, what that means is that we don't just have one dimension. You can think about this as having a list of lists. So you have one list, so we can have 1, 2, 3. And inside this list, we have another list in here. Think about it like that. So in our case, what we are looking at now is we have this list, we have another list. Let me write it and you see np.array, comma, brackets. Once we created this bracket, we create an additional bracket. And inside that first bracket, we had 1, 2, 3, 4, and 5. Then we come out of that first bracket, we put a comma, and we have another bracket. We have 6, 7, 8, 9, and 10. I just rewrote this so that you see the brackets. Sometimes these brackets can be like confusing. So we have like a big list, and inside it we have other lists. So what this means is that with that 1D array, we just index straight away a 0, then we are looking for the first value. In this case, if you say a of 0, it wouldn't return you this value. It will return you the entire first list. That's this. So if we say a of 0, it usually will retain all of this. The same way that if we say a of 1, it will retain all of this. But that's not what we are looking for. We are not just looking for the entire of that row. We are looking for a specific value. So we pick the example of wanting a 1. So we first of all would say a of 0, which first of all gives us the entire list. We've made progress. So now we have access to this. We know that to be able to access the first value in that list, we just need to index it by what position it is. And in this case, the first position is always 0. So we are going to say we have selected the first row and comma another 0, which means that we are looking for the first value, which is what? A 1. The same way that if we wanted the second, which is 2, we have A of 0, which selects this entire list, but we are looking for the value 2. And 2 has the position of what? 1. So we say comma 1, and that gives us a 2. If we are looking for, let's say, 4, we are saying that we are selecting A of 0. And once we have A of 0, and we want this 4 has a position of what? 3. So we have comma 3, and this would give us a 4. So that's basically like how we do the indexing. So I mentioned, I said 0 of comma 3, what was it going to return? And then some others already mentioned 4 4 4, like Isaac said 4, Allah said 4. So if you said 0 comma 3, what that means is that you want this first row and the one with the third position, which is this. Okay, there's a question Frank asked. So you are saying that A of 0, then A of 1. So you want to select A of 0. So A of 0, that's like just still the same row. And you want what? The one with the first position, which is what? 2. So it's the same thing. So what if I want to select, let's say, 8? Anyone who would know how I should index to get the value 8? If I want the value 8, how do I get a 8? Still using the same ideology. Remember that this entire list has a position of 0. This entire list has a position of 1. So if I want the value of 8, how do I get 8?
I think,
You can write it in the chat.
go ahead?
Yeah, sure.
So I think you would write A of 0,
A of
comma,
0.
and then comma 2.
2. It gives us a 3. Why did you think it would be why did you start with a 0?
Okay, A of 1, sorry. I'm just
Okay,
carried
A
away
of
with
1.
the 0.
Okay, A of 1, yes, and then 2, right?
Yeah.
So yeah, that's because this is the position. This entire list gives us like the index is 1, and we are looking for 8. So 8, again, in this list, we are going to start counting position 0, position 1, and position 2, which is what? 8. So we have 1 comma 2. So that's really how you do the index. If you have a 3D array geology, and then you burn it. So that's how you do this selection. There's something I want to mention also, that we can also do indexing in a reverse way, which we call negative indexing. So in this case, we are just indexing with positive, like 0 1 2 3. Now we can rather go and start like from the back of the list, kind of counting. So what that means is that instead of just starting from the first and we have 0 1 2 in increasing order, we rather start from the opposite and use negative. So if we have a list this, and then we want to get this last value. So instead of saying 0 1 2 3 and 4 and say B of what? Of 4 and having 5, we rather just say we are going to start counting from the back. So we are going to have -1. So with the negative slice, and it doesn't start with 0. Of course, we don't have -0. We have -1, and that is that it's starting from the back. So you have -1, then this one will be what? -2, -3, -4, and -5. So we want this last value, then we'll have what? And this will give us a 5. And so actually in doing this, you can either do the negative slicing or like using the normal slicing with the zeros or the negative. There are some people with this, others also prefer to use the normal one. But of course, if you are probably let's say working on an example where you want to always pick the last value, then it rather makes sense to always use the negative indexing, because you know that you just want the last value. So if you use the negative index, you get the last value and do whatever you want to do. I mean, maybe you're working through a project and you do a for loop, and with the for loop you're doing, you want the last value to complete the task. This is like the easiest way to go about it. So that's how you do the indexing with the negative slicing. So it's pretty much the same way like we understood, just that know that instead of doing positive, you negative. We move to the second part, which is NumPy slicing. So with the NumPy slicing, what is that? To select a series, like a series of elements from the list. You want to work through with them and do something. You just don't want one value like we're looking at. You want to cut some portion out of it. And slice, two major things you should know. You have like whatever you specify the start and then the end. Sorry. You specify the start and the end. So what that means is that the square bracket in it, you have the start, and then you have semicolon, and then you have the not semicolon, the end. So you have the start, colon, and end. So what that means is that the value you put here, but again, remember you're putting the positions, just like we learned how to position, like index 0, 1, 2. So whatever value you want to start with, the position is what you write here, and which position you want to end, you put that there. So for an example, if we pick, let's say this array, and then we decide that we want to start from 1 and maybe 3. 1 has index of what? 0. So we have the column, and remember that 3 has index of what? 2. Do you think that I mentioned something? Do you think that if I write 2 here, I will get the 3, or it will end at 2? There's something we learned earlier. I mentioned something that usually with Python, if you want the thing to end at one particular element, you have to add like +1 so that it includes that last element you want. So if I say 0, which means that it's starting at position 1, and I want it to return all the list between position from position 0 to position 2, which is this 3. And I write 2 here because 2 here, this is 3 is position 2. Do you think it's going to give me 3 or not?
Yes.
End at 2. In case we don't know the last value of the data, will the negative indexing still? Yeah. The negative index will give us if you don't know the last value. Yeah. Okay, you said it will end at 2. Yes. So it will end at 2 because remember, Python indexing starts at 0. However, when you are counting till the end would always stop at what? Like -1 of what you have indicated. So if you wanted to proceed and include that value you want, you have to mention the other index like +1. So in our case, we wanted it to end or include 3, and 3 has index of 2. So instead of 2, we should have made it 3. In that case, it will add 3 to us. So it's more like we indicated that 3, but usually it wouldn't always add this last thing. These are very important things that sometimes it can bully you. So please be very, very careful. Number 1, Python counting starts at 0. Secondly, if you are looping or you are indexing or slicing, you should know that it doesn't always end at that value you indicated. It will end at -1 of that. So if you say index of 4, it wouldn't include the 4th value. It will include 4 minus 1, which is 3. So be very careful of this. So in this case, we have this NumPy array again. We have 1, 2, 3, 4, 5, 6, 7. And then we say you should return 1 to 5. What numbers do you think this is going to return? What numbers will it return? 1, 2, 3, 4, 5, 6, 7. So we are indexing 1 to 5. What numbers will it return? Any ideas? Okay, yeah, there's some chats. 2, 3, 4, 5, 2, 3, 4. Okay, let's see if it's 2, 3, 4, 5. I can't close this chat again. Okay. All right. So 2, 3, 4, 5 is what we have. So basically it's starting at 1, which is what? That's position, sorry, position 1. So position 1, position 2, position 3, position 4, position 5, position 6. And we wanted it to include what? 5. So instead of leaving it at 4, we said position 5, and it gives us this. So be very careful of that. The other one I want to mention is also that usually if you do not indicate where it should end, so that I said it starts and end. Start and end, those are the major things, right? If you do not indicate where it should end, what you're telling Python to do is that it should, you're not giving end to it. So in this case, we want it to start at 4 and end at the end of the list. We are not specifying that it should end here. This is very useful because if you have a very big list, there's no way you can sit and be counting that, okay, this is the last position, so this is what you should do, right? So if you do this, you don't know the position of the last value. So if you do this column the last, then that means you're telling Python that it should end at where the list is ending. And equally, if you mention you don't put anything at the beginning, you're telling Python to start at the very beginning, position 0. So if you leave it semicolon, the start, you don't put anything, you're asking Python to start from the beginning till you want it to stop. So in this case, you said it should stop at position 4. On the Python should that give you to the end of the list. You don't indicate anything there, and it gets to be beating me. So that's with the indexing. You can either index from the beginning to the index of whichever one you want, or the also we have the negative slice, and again, also in this case we can do the negative slice. So in this case, -3 to -1. So we're asking that we want it to return the list from -3. We length -1. So quickly, what do you think this will return? Remember that with minus, you are starting from back. You're going to -1, -2, -3, -4, blah, blah, blah. So if we have index of -3 to -1, we are slicing. What will this return us? This particular one here, I've highlighted. What will this return to us? Don't forget, we are starting from the back. Five, six, seven, 5, 6, 7. Okay. 5, 6, 7. 5, 6, 7. Any other? 5, 6, 7.
It would give only 5 and 6.
Jamila,
Because
why do
you
think
said
it's 5 and 6? Everyone else thinks
you
5, 6, 7.
said
Your network. Kojo also say 5, 6. Okay. I want to know, some others are saying 5, 6, 7. And that we have 5, 6.
The last number you are calling. Can you hear me?
Yes, we can hear you now.
I said you said earlier that Python always reads the last number minus the minus one of the last digit you are calling. So if we say -3, that starts from 5
Right.
to -1. So -1 minus 1, that is 2. So it will only give us the 5 and 6. So it will give us the -3 position and the -2 position in the array.
So basically, it doesn't always include the last value. You remember when we were doing the positive one, when we say 1 to 4, it will give us 1 till position 3. It won't add the fourth one. So in this case, it wouldn't include the -1 position. It would just include the next one before it, which is -2 position. So again, I'm repeating myself. Python indexing starts at 0 and you continue. If you're doing the negative slicing, it starts from -1. However, if you are slicing any Python list, it doesn't always include the last element you have indicated in the slicing. So if you wanted to include some elements, you have to add like +1 so that it ends at that side. Okay, so quickly, I want to finish up with this and go to pandas. So we have, like, I mean, we saw some few of thoughts. We had zeros, we had ones, we had linspace, we had arrange, we had I. Also, we can find like the maximum of a list, the minimum, the argmax, the argmin from any list that we have. Like NumPy has that. So basically, all we would always do is that, okay, we want a NumPy list, then we can use them. We can find the maximum, the minimum from it with through NumPy. So these are like different methods that we have. I just mentioned a few, but there are a lot. I honestly, I don't know all of them. So there are a lot. So if you're someone who wants to be an expert in NumPy, you can go, the documentation is there. You can get a PDF version and sit and be reading it, and I mean, try as many as possible, most of the things that they have. And yeah, so I mean, it depends on what you want to do. Other work projects, can always go through them. There's another important thing that I would mention, it's which we call in NumPy that we call broadcasting. What that means is that that's why most people actually prefer NumPy to normal list. The reason is that sometimes you want to carry out an operation with one single number and multiply by a series of lists. So let's say that I give you ages of students in the class, and I'm coming to work with the ages, but first of all, I want to increase everyone's age by 10. In a normal list, you have to now sit and say, okay, 10 plus this person's 10 plus that person's age, 10 plus that person age. In NumPy, I count your ages. I would simply just add 10 to the lists, and then it will automatically spread the 10 across all of your ages and add. So for instance, in this case, I want to multiply a number by 2. Okay, so the NumPy array is 1, 2, 3, and I want to multiply by it by 2. So instead of having 2 times 1, I simply would just say 2 times what? 1, 2, 3. What NumPy does, but of course, you are not like, it's not doing it for you to like see, but it sort of stretches the one value you give to it. So like in this case, we want to multiply this whole list by 2. So it sort of creates imaginary or stretches these 2 so that it becomes the length of 1, 2, 3, the length of that array, so that it's able to multiply each of them and doesn't take so much time to complete as compared to the normal list. So usually people would, I mean, prefer to like use that than the like creating a list and then multiplying it and all of that. So usually that's like basically what broadcasting is about. You'd really use it a lot when you are, let's say, working through like ML projects, and or probably you're coming up with writing a function and you want to be able to complete a task. You wouldn't want to like sit you want your function to be like efficient, like time efficient, and doesn't use so much space. So usually broadcasting would be efficient method. There's a lot about broadcasting too as well. I think I'll share a link to, I have some resource on that. I'll share a link with regards to that. But I want us to briefly, and then there are exercises that I have put here with solutions. I got this very nice link with NumPy, different exercises and solutions. So if you want to take a look at it, you have access to this, you can have a look at it as well. So I want us to dive into pandas before we go to working with the data sets that I prepared as well. So pandas is also another library in Python, and majorly we use this for data frames, like manipulating data sets and all of that. Like I mentioned, with data scientists and machine learning engineers, you will surely be working with data, right? So pandas is like your go-to tool that you should be like excellent in. And so it helps you like analyze big data. It helps you clean messy data, and also I mean, being able to have data set that is in a good state, like well clean and all of that, it's something that is pretty much important in ML or any data science project that you work in. So to install pandas, you can also install it using Conda, like we saw. You can also install using pip install. But of course, if you have an Aconda installed, you don't need to do all of these installations. You would have them completely installed for you. And to import pandas, you import it. I mentioned that import is that one word that you really need. So import the name, which is pandas, as PD. This is just convenience sake. And for most ML projects, you always see them importing it as PD. I could import it as D, I could import as E, anything, but it's a conversion, like it's PD, NumPy is NP. So it's like everyone, when you pick the project, you already know. When you see NP, you know what it is. So with pandas, if you want to create a data frame on your own, what you need is PD dot data frame. Remember that this D starts with a capital and the frame is also a capital. So it's data frame. And in the data frame, we have this. So I mentioned that the D is a capital, the F is a capital. So you open brackets, and inside the brackets, what you want to do is you want to first of all create a dictionary inside. If you joined our last month's meetup, you probably would have seen dictionaries from Khadija's tutorial. So you create a dictionary. So this is a dictionary. So you have a dictionary in, and inside the dictionary, first of all, you have a key. So let's say this, we named it as group. And in the group, we provided the values that we want it to be in. So like you can think this group as like one column we have created. So the first column we have created is group. And this group we said is taking values. These are the values that it's taken. Then the second column we want to create is what we call answers. And in this case, we have it as that. We create answers, and that's the second column. That too, we have its values. And basically that's how we create a data frame. So you can add an additional row by just comma and then giving the name of the additional row you want, and then given the series of lists that should match with this, whether it's numbers, blah 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 blah. And once you run this, then you have your data frame created for you. But I mean, you may be creating data frames in some projects on your own, but most of the time with us, it's more like you have the files, like you have a file, then whether it's a CSV file, an Excel file, we'll see how to load them. You just upload or load them in with pandas, and then you work through with them. But if you have to create a data frame, that's really how you create it. There are also methods that we should know about in pandas. One is being described. So with describe, what is giving us is computing summary statistics. So in this case, we created a data frame called data. And when we ran this, it had two columns, group and answers. So when we call this name of the data frame, which is data, and say data.describe brackets, what it returns to us is the column. Like, so if we have several columns, it's going to, first of all, count the column that we have. So like in this case, ounces, it's counted the values there, calculate the mean, its standard deviation, it gives you the mean, the 25% percentile, 50%, and 75%, and then the max value, right? Remember that this 50% is also like the average, right? So sometimes it just gives you quick information when you are exploring your data, because I mean, I just showed you how to create the data frame, but in the event where you're given a CSV file, you upload the CSV file, which we'll be doing in the last session. You upload the CSV file and you just want to have a brief idea of what the data set looks like. What is the mean? What is the standard deviation? How do the values deviate away from the mean? What is the maximum value you have in it? Do you really have outliers? So this describe is just a quick way to have like a first level overview of what is in your data set. So it's something that usually when you're working with data, the first thing you go to is to do this, to just get the summary statistics. So once you do this, you could decide to also go ahead and do other stuff. Like you want to be able to sort your values. So you think that, okay, we have a column called answers. So you want to be able to sort the values in the data set based on the number of answers that we have. So you create data, and again, the name of your value, and then this is another function, sort values. Again, just like we had in NumPy, there are several of these methods too in Pandas. There is documentation for Pandas as well. So you can explore them to see what are the different methods that exist there. I always make reference to the availability of these things because I believe that sometimes you learn best on like by yourself, by exploring stuff. So usually I would prefer to like teach you how to get the information rather than to just give you the information directly. Sometimes I may not even know. Other times, even if I know, I prefer to still guide you how to get it. So the next time, if you are stuck, you wouldn't have to come back and ask, you know how to go get the information. So please try later. You can check for documentation on Pandas, NumPy, and just see the different methods that exist in them. So in this case, we have the sort values, and in this sort values, it takes the column that you want. So in this case, we wanted to sort by the column called answers. We are still working with our data sets, this data set data. So we want to sort it by the answers, and we specify ascending. So which means that we want it to be in ascending order. So from the minimum to the highest. And in place, what this means is that we don't want it to make any changes to the original data set. So the original data set still remains the same. Sometimes it's important to always like put this in place to be true or false. If you really want the data itself to change according to how you are manipulating it, it's important to put it in place to be true. Otherwise, if you're just trying something, you probably want to put it as false. So in this case, if we run this now, we notice that this data set has been sorted in the sense that now the answers has been arranged from the minimum till the highest. So you have 3, 4, 6, 7.5, 8, 12. And for each of it, you still have their groups. You just notice that the values have been like, you have this as 1, 6. Unlike here, we had 0, 1, 2, 3, 4, 5. I mean, it just rearranged them based on the one that had the answers to be the minimum. We could also resort it by group, and then I mean the group and then the answers. We have 2 columns in our data. So we can resort it. In this case, we are sorting by group, we are sorting by answers. So we have the group, you notice now it has sorted it in a way that you have A, B, B, C, C. And that's because, I think I don't want this. That's because we want it as A, B. Like we are sorting based on this group, not on the answers. So now this group has been sorted based like accordingly based on which alphabet should come first and which should come second. Also, we can create Pandas data frame using series. So what that means is that a series, you can think about a series as a single column that we have. So we can create a series. It's also just like how we saw how we're creating earlier data frame, we just put all of this information inside here. But this time around, we created like a series. So we created calories, we created duration column, put in the values that we wanted, and then we called all of this series. Then we put series into this data frame, and this would still give us a data frame that we want. I mean, this and what we had, it's like largely the same thing, just that instead of renaming this differently and putting this, we just put this in and then we got our data frame. So now we had this data frame as calories and then the duration. Another important part when it comes to exploring data is being able to select data. Like when you have the data frame, being able to select what column you want, what row you want. And then once you select them, you can work through with them. That's really what data exploration is about. You're exploring your data, trying to understand it better. So just like we saw in NumPy, we had indexing and selection. In Pandas, so we also have the ability to index data and then select data. Here we'll be looking at 3 major ways to do indexing. So this we call the indexing operator data frame. We also have the data.log, dataframe.ilog, and dataframe.ix, but this is like has depreciated, so I wouldn't cover this. I'll cover the first 3, and we'll do that by looking at a data frame that we created ourselves. So we create a data frame we call series, and in this we had calories, we had the month, we had duration, we had names, we had location, we had prices. Okay. So again, it's just like what we did earlier. So we are just creating, it's like a big dictionary. And inside the dictionary, first of all, we'll provide the name of the column and the values that should go into that column. Then we provide the second column, what should go in there, third, fourth, fifth, sixth. So when we run this, this is the data frame we have created. Okay. So it's a just very small data frame just to help us understand these things. I should mention that what we have here, 0, 1, 2, 3, you can think about them as like the row labels. Okay, in some circumstances, you wouldn't have them as 0, 1, 2. You have like actual names that they have. But for this particular example, we didn't specify the names of the rows. So it automatically just names it as 0, 1, 2, blah, 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 till 10, till 11. But sometimes you can create it and then rather include what the row labels should actually be. So they wouldn't be numbers, they will actually be labels in themselves. So first of all, we are going to look at the first way to index data, which I said the indexing operator. So with the indexing operator, what we do is that we just need the name of the column. And to get the names of columns in any data frame, you just need the name of the data frame you have. So in our case, our data frame is called what? DF. So we are going to say DF dot columns. So if we run this, it gives us the names of all the columns that we have in our data frame. So you see calories, month, duration, names, location, prices. If we go here, it's the same thing we see. These are the column names we have. So now if we want to select, let's say the column called calories, so only this column, sorry, why does it select? Only this column, calories. All we need is the name of that column, which is calories, that's DF, and the name of it, calories, and it gives us the values. If we wanted, let's say, duration, then we just put this in there and run it, and it gives us the duration. And this is the duration. I mean, this data doesn't mean anything. I just came up with something. If we want names, we put this there, and then it gives us the different names that we have. Kwame, Ama, Kwesi, Kojo, Eboa, Bena, Ikria, So that is how you select a single column. You may want to do something, want to work with only location, you load the data and you want just one column. This is one way to do that. You may also want several columns. And if you want several columns, the difference between selecting one column and several columns is square bracket. If you want one column, you are selecting only one column, you just need one square bracket. But if you want several columns, make sure you have 2 square brackets. if you want to select one column in your data frame, you use one square bracket. But if you want several columns, let's say 2, 3 columns, make sure that they are two square brackets. So in this case, we have df, then we have the 2 square brackets, and in it we have the names of the columns we want. If we run this, this works. But let's say if I had decided to make this a 1 column, it's going to throw an error. So this throws an error. Key error, calories, location. So it's important that you know that if you are selecting several columns, you need a double square brackets, and then that would help you select the columns that you want. That's for multiple column selections. There's other part is the data.log. So with the data.log, that works by selecting, like, it helps you, you can use the row label names. So when I started, I explained to you that this 0, 1, 2 that we had here, they were automatically generated, right? Because I didn't specify the index of the row labels. But sometimes you can have names for these rows. So if you have names for them, if you want to select based on the name, so let's say if here was called, this 0 was rather had a name, let's say yellow, I wouldn't, if I'm to use the log, I would say .log, then in quotes, and write the name that I want, because it's the name. Okay, but in this case, they are numbers, so we're working through with the numbers. So in this case, I want df.0. What that means is that I want the first row here. So it's going to return me the values for all of the first row. So if you say df.log, you notice it returns calories, the value for it, month, January, duration, 50, names, Kwame, location, Tamale, prices, 1,400. If I want, let's see, the first, the second row, that's 380, February 40, Ama, Bupe 3,200, then I simply would just change this to 1, and then I have that information. We could also select multiple rows, right? So we can select row 0, row 1, row 3, and then if you run this, then you have these values. Okay, that's using the log. So basically, you can think about the log as helping you select like row wise. On the other hand, you could also combine the log to select the row and then also the column. So in this case, let's say that we want the first row, the first row, the second row, and then the sixth row. Then we have 0, 1, 5. But then we don't want all the columns. We want calories, we want month, and we want names. So we simply would just have df.log. We had df.log, and in its 2 square brackets. The first square bracket is where we specify the rows that we want. And then the second column would now be the columns that we are looking for. So we have this. And then if we run this, it gives us 1, 2, 3, because we wanted 3 rows, which is the 0. You can see 0. The first, that's 1. The fifth, that's this. But we want calories. We have calories. We want month. We want names. So it returns exactly that for us. We could also decide that we want to select all the rows. So thinking or taking our back to NumPy, how we're indexing, you can simply replicate all of that in Pandas as well with the indexing. So you just have to understand how the indexing works. And once you're doing Pandas indexing too, it's easy to blend them. In this case, if we want to select all the rows, in selecting all the rows, we just do semicolon. That means we want all the rows, and we specify the columns that we want. In this case, we want calories and month, and then it will select all of this for us. But this is all the rows that we have in our data frame. We could also select the 4th row and all columns. So first to 4th row. So we have 1, 2, 3. Then we have, this is first to 3. It wouldn't select the 3rd column, it will select the 2nd. So if I want this, it should be this. And then all the columns. So if we run this, we want 1, 2, 3, 4, and 5, right? So and then all the columns. So all the columns, we just do semicolon, we don't write anything, and it selects all the columns that we want. That's how the log works. With the iLog, we can retrieve rows and columns by the position that they have also. So it's literally like similar to log, but however, in this case, we had, I mentioned that these could be like labels themselves. So if they were labels themselves, we can only use what? The log to get the name specifically, but we can't use the iLog in that case. But the iLog, we can only use the position, what position those rows are. So with the iLog now, it's literally just similar to log. So if we say we want iLog 3, so we want the one with the third row. So the one with the third row, if we run this gives us the information for the one with the third row. And we can also select all the rows and some columns. So this is all the rows, and then we want column 1 and column 2. And that should give us month and duration. So there are other methods. So we have methods for indexing, and sorry, this is not other methods in pandas. Other methods in pandas. So you have data frame.head. So this one will return the top n rows of the data. We have data frame.tail, data frame.shape, data frame.shape. Like there are a lot, right? So I just included a few of them again, and you can, like, when we are doing the real example, you can practice on this. Finally, we want to look at if you are rather given, you don't have to create the data, right? You are given a data frame. So let's say you're given a CSV file. How do you load it to pandas? If it's a CSV file, all you need is pd.read.csv, and then you put the name of the CSV. So this, I said data.csv, but you put the name of the file, CSV. But just make sure that you have this file in the same location. If you're working on a local machine, make sure that the file, the data frame file, is in the same location as the script you are working with. So if it's a Jupyter notebook, the Jupyter notebook and the data frame are in the same file location. So all you just have to do, you wouldn't have to put the pathway. You can just write the name of the CSV file, and that's it. But if they were not in the same location, then maybe you want to put the path to this data, which I don't know. You have to check it from your computer, what is the pathway to it and to the data frame. But it's usually easy if you just have them all in the same folder. So that's how to read the CSV file, pd.read subscript CSV, and then the pathway data frame. For JSON file is pd.read.json, then you have the pathway to the JSON file. Then for Excel file is pd.read.excel, the name of it. So you can have the name of it, comma, which sheet in particular you want to load. You know, Excel, you have several sheets. So whether it's the first sheet, the second sheet, the third sheet, you can include that. And HTML files, read HTML files, and then you can put that pathway to there. But you could also, sometimes you can load these things and have errors. Again, if you have an error while loading one, copy what the error is and search on Stack Overflow. You would surely find some suggestions on maybe what you're doing wrong. And all of these sometimes have extra things you can add. Like this, you can have like a header, you can say the header none, or you can have some more information. Sometimes you are loading a data frame that has some Unicode characteristics, so you need to include all of that. But that depends, right? So that's with loading files with pandas. Then finally, there are some examples from W3, which they have examples on pandas with exercises that you probably would want to try. Now to the final part and the exciting part for me, which I said it's really nice when you work on things by yourself. The final part is working with a Titanic data set. So we are sort of going to just try with the data set itself with these things that we've learned. I'm going to share this link. It's a Google Colab. And in this link, once you open, just go down. So you can just use, I included, you can just click working with Titanic dataset. It takes you right down to where you need to work through. Here I mentioned that we are going to work in breakout rooms. Okay. So what we are going to do is that I'm going to create a breakout room of three people, and in each breakout room we would have someone there who will be guiding you, but whoever is there is not going to do the coding for you. The person is only there to guide you. So one of you in the breakout room should share your screen. Open your notebook and share your screen. And the rest who are not sharing their screen would have to tell you what to write. Okay. So what is going to happen is that you would always see to do import NumPy and pandas. I've indicated that you should import pandas, NumPy and pandas. Okay, so just like we imported them, how would you do that? So you try to include the code here. So you can say import NumPy as NP, import pandas as PD, and then you run your code. And if it works, yay, that means you've done it right? But if you're not sure how to do it in your stack, you can double click and then you see the code. I've included the solutions to the code. So you can double click it and you see the solution for that. But please try to do it yourself before you double click to see the code. Like for all of them, the code is there, right? But you always have instructions on what you should do. So the first part I'm asking is that you should import NumPy and pandas. So import it. The second is that I'm asking that you download Titanic data using pandas and name it as DF. Okay, so you load the data. We saw how to load a CSV file. Load it and name it as DF. Okay, then if you're not sure, when you try, you're not sure, you can see the solution. Then the next part, I'll ask you that you should check the shape of the data. How many columns and rows do you have? The second part is what are the column names in the data sets? I want you to be able to check for that. I've asked you to use information to check how many entries we have in the data. It would give you information like this. You should be able to get your solution like this. It should return something like this. Then I asked to return the top 7 rows of your data, okay? And just, I asked you to refer to section 2.4 of this notebook. So if you go to section 2.4, it's here, methods for indexing data. It's not indexing. You go here, and if you read some of these things, we have data.head. I said it return top n rows of a data frame. So if I ask you to go to 2.4, which means that the solution to whatever problem you are solving would be there. So you make reference to see, you can read through and see what information you need from there to help you solve that. But this should be what you should be able to retain. I asked you to do descriptive like we did, and you should comment on the results. So all of you in the group should discuss, what do you see in the results? What do you observe? The number of passengers who survived. So you should be able to select the survive column. So whatever it is, I have included the instructions really clearly. And again, the volunteer in your room is not the one to do these things for you. You have to do them yourself. You need to learn by doing. So I'm going to create the breakout rooms now. And please try as much as possible to share your screen, okay? So if that is clear for everyone, I'm going to share the notebook now. And then we try, right? Is there any question, first of all? Any question, please? So I've put the link to the Colab there. I'm going to share a second link, which is a link to the data. If you also have what do they call it, an Anaconda, and you're comfortable working there, feel free. Okay, it's not a must that you have to use the Colab. You can use the Anaconda as well. You just have to download the Colab. You just have to download the Colab, and once you download it, you can work with it. So let me show you. If you have Anaconda, because I asked you to download. So if you have it, you go to file, and then once you go to file, there's download here, and you have download.ipynb. Please download that one and then open with Anaconda. So just click download, and then it will download the file for you. Then you can open via your Anaconda directly. Okay, so I'll create the breakout rooms now. Okay, Khadija, do you have an idea? It looks like I don't see the breakout room option here.
Yeah, I think I can create it from my end.
Okay, then you do that then. You can create 2 breakout rooms. Just create 2 breakout rooms.
Okay.
Even that be ranching.
I have created the rooms now.
Okay. Kadi, is it possible that I can switch and enter other breakout rooms too? Yes, Allah, we'll have another session. We'll have another session after the session next month. Isaac, Kobe.
So come to we won't talk about artists within nation. We know that it's kind. Yes, sir. I will get there, but good time to go. Hello. I know. Maybe you're born now.
Hey, Kobe. Okay. So, Hadija, I think we have everyone back, right?
Yes, I think so.
Okay. All right. So I think I'm sure that I don't know how far you went in your group, whether you were able to finish the notebook.
No, we're not able to finish up.
Okay, no problem. So I would say that probably I mean I don't know, but I think because I shared it earlier and there were edits that we made, I seem to have lost the parts where I included show code. So I'll later try to put in the codes again and hide them. And you all have links to the notebook. So I would make it in a way that you can edit directly and share the link again. And you can work through or check through for the solutions yourselves later because we can't finish all of this. But I think it's really good if you're able to finish this app because this is more like I mean, it's just beginner trying to understand, manipulate stuffs and try to understand what's in your data sets. And this is really what it's about when it comes to exploring your data or trying to understand your data well. But the final point I want to mention is that when you're learning programming language or anything, it's more like learning a new language. So you can think about English, you can think about German, you can think about French, etc. It needs like constant practice every day, right? When you're learning a new language, that's what you do. So whilst you're also learning programming, take it like you're learning a human new language, like any of those languages I have mentioned, and try to like practice something daily. And if you are not sure of doing something, I mentioned earlier that you should go ahead and use Stack Overflow. Trust me, if you come and ask me or ask someone else, it doesn't mean we always have the answers. We maybe if you ask, I also have to go check on Stack Overflow and then try to understand what could be the potential solution and advise you accordingly, right? Um, so if you don't know, the first thing you should go ahead to do is Stack Overflow. Maybe if you don't understand, then you can now try to find out from someone how to go about the problem. And also, instead of sometimes copying and pasting code, it's really nice that even if you are not sure on how to do something, you find a code somewhere, take your time to write it out word by word yourself, just like you are saying, and run it. Don't copy and paste and run, because at the end of it, you sometimes don't know the little things like the brackets, comma being somewhere and all of that. So it's really nice if you always write them out yourself and try to read other people's code as much as possible. And you don't have to freak out on errors, okay? Just try to read errors and try to understand what they're asking you to do. If you're not sure, Stack Overflow is your solution to really get this problem solved. And finally, I know that some of us are also like learning these things to look for jobs. So I included preparing for technical interviews because most of these companies usually would ask you to do like technical interviews before like they do their final selection, right? So you can try using resources like HackerRank, which the link is there, LeetCode, Code Wars. You can try all of these, try to practice as much as possible. And these are the list of references that I used to develop the notebook. So you can make references to them at any point in time. So that brings me to the end of my tutorial for today. And yeah, thank you very much. I think I took more time than I estimated.
Yeah,
Thank you.
thank you very much. We really enjoyed the session, and we are hoping that everyone here would make it to our next meetup session next month. And in the chat, I've also included the links to our meetup and then our Twitter page. So please join the meetup and follow us on Twitter as well. And those of you who are not on the Telegram page, I think you can find the link to the page on our meetup. So thank you to everyone today, and we are hoping to see you next month for another interesting session. And thank you very much, Deborah. This session was really insightful.
Thank you very much for having me. And feel free. Yeah, if you Kojo, if you registered or by either you joined the meetup group or you just registered to join the meetup with the Google form we sent out, I would send the links and other things that you need with regards to the notebook. And please feel free to reach out if you have questions or need suggestions or anything. I mean, nobody's a custodian of all knowledge. I may not know it all, but feel free to reach out if you have questions. And once I know, I'm happy to help. Yeah, and thank you very much, Khadija.
Okay. So, bye everyone.
Bye. Have a great week.